Let's dive depth first into React compiler. But wait a second. Why do we even need the React compiler? What is the need for it? So let's see. Imagine that we are building a shopping application. Now look at the code. First we normalize a search query, and then we filter the products, and then we create an object for the card style and add a function for selecting product, and then we take all of this and we simply render the list. The problem with this is that every time the component re-renders, the JS is executed from top to bottom. We will have a new normalized query, we will filter the product again, and we will have to create a new card style object, even if nothing related to that has changed. And the reason the child re-renders is because JavaScript compares values by references. So even if an object or a prop hasn't actually changed, it holds the exact same value. A new reference is created and passed down to the child. So child sees a different reference, treat it as a new thing, and it re-renders. So just to be clear how far this goes. So let's see these two objects. They are not equal in JavaScript. Yes, they have the same content, but they are treated as different objects, and that's all React is checking if it decides whether a prop has changed. So even if a new theme has never come, the theme has never changed, the card style is a brand new object on every render, and the product list re-renders for no reason at all. Same story is with handle select. It is a brand new function every time a component re-renders. Now, to solve this problem, we used to fill up our code base with useCallback and useMemo. So what are these actually doing? useMemo caches the result of a calculation. You give it a function and a dependency array, and the React runs that function once and hold on to the value. Onto the next render, it looks at these dependencies, and if nothing in that array has changed, it hands you back the exact same value. And if the reference has changed, it then it recomputes it and then hands back to you the value. Now, what use callback does? It does the same thing, but it does that just for functions. It caches the function's definition itself. So if the child receives the same references across re-renders, instead of a fresh one every time, it gives you the cached function definition. And that's it. So both of them exist for one reason, to keep references stable between re-renders. Now, card style only becomes a new object when the theme actually changes. Handle select functions also stays the same, and the product list stop re-rendering for no reason. So the problem is solved. Except, look at what we have done to the code. The logic didn't change at all. It does exactly the same thing it did before, but it's now buried under wrappers and dependencies array. And the actual intent of the code, normalize, filter, style, and the render, it got harder to read. And that's the smaller problem. The bigger one is that we had to do and figure out all of it manually. Every single time you wrote a function and created an object inside a component, you had to stop and ask yourself, does this get passed down? Will this cause an unnecessary re-render? Does this need to be wrapped? And you had to get it exactly right in both the directions. You miss a callback and you get silently re-renders that nobody ever notices until the app feels sluggish. Wrap everything, and then we are maintaining a dependency array everywhere, and the stale dependency array will cause problem. It will show the user old data. So here React ended up in a strange place. To use a library whose whole promise was just describe your UI, and we had to constantly think about references, renders, and caching. So if you take a step back, how did we solve it? What we were actually doing when we sat there deciding what to memorize, we were reading our code, tracing which value is dependent on which, and inserting caching at exact point where a reference needed to stay stable. That's static analysis. We were the static analyzer. And that's the question someone on React eventually asked. If figuring out what to memorize is mechanical analysis of the code, then why is a human being doing that? Now, this is where React compiler entered. React compiler is a built-in tool like a Babel or SWC plugin. It's important to get that part right because it doesn't run in the browser. It runs when you build your app. It reads your component code and it inserts all of that memoization for you automatically only when it's actually needed. So, which means you go back to your which means you go back to writing your code like you used to do before, like the first version of it, the plain one. So no more wrappers, no more dependency array. And at a build time, the compiler rewrites this into an optimized version before it ever reaches to the browser. And here's the detail that surprises most of the people. So it's worth saying clearly, like the compiler does not go and wrap your code in useMemo, use callback. It doesn't use all of those APIs at all. It inserts its own memoization logic at the compile time. And that logic caches at a more granular level than those hooks. useMemo can only cache the thing you wrap, but the compiler is working at a whole different level. It can cache pieces of a render that you couldn't have isolated by hand. So now the interesting part is how it knows what to memoize, because memoizing wrongly is very dangerous. If it caches a value that actually should have updated, you get a stale UI. So the compiler can't just cache everything and hope for the best. It has to prove that a value only changed when specific inputs change. And the way it can prove that is comes down to understanding the rules of React. The React have rules like a component must be a pure function of props and state, and you don't mutate value during re-renders or renders. Hooks are called in a consistent order. Now think about why do we have those rules? If a component is pure, then the same input always produces the same output. If the input didn't change, the compiler knows it can reuse the previous result. So you were allowed to mutate if you were allowed to mutate anything at any time, none of that reasoning would hold, and no compiler could ever safely cache anything. So the compiler analyzes your component under those assumptions that work out. Which values depend on which, insert caching at exactly those boundaries. So take our card style for example. The compiler traces it and sees it depends on nothing but theme. So it caches it against the theme. The query changes, the component re-renders. The card style is handed back as the same object, even like it was before. So the product list does not re-renders, and we didn't write a single hook to make that happen. React compiler did all of it. But the thing to notice here is React compiler powers come from those rules. So if your code breaks them, then what? In that particular case, compiler just skips the component and leaves it alone. So the warning the compiler didn't optimize this component is actually not compiler problem. It's a compiler telling you your code is doing something it can't prove it's safe. And that's why React ships ESLint plugins alongside it. So it surfaces that analysis in your editor. One more honest thing before we wrap this up, because this is where people get the wrong idea. It does not mean that useMemo and useCallback are gone. They still exist, and their role has been flipped. They used to be default tool you reach for every now and then, but now that they are just an escape hatch for if you need them in any rare case to give you a manual control if over things that the compiler isn't giving you. So for everyday code, you don't need to write them anymore. And I think that's a real shift. For years, React asked you to think about rendering cycle to manually manage references, so the framework comparison came out right. The compiler takes that entire category of thinking out of your plate, which if you think about it is exactly what React promised. It started with describe your UI as a simple function of your data and let the framework handle the rest. That's the whole point of this channel. One level deeper, then it just works. See you in the next one.